The use of concepts from cognition theories as compositional strategies for creating new works for guitar, by Eduardo Frigatti, Maria Curie Skłodowska University. With the dissolution of tonality and the emergence of an aesthetics based on sonority throughout the 20th century, composers sought various ways to reflect on their compositional poetics and artistic craftsmanship, attempting to solve problems such as the creation of new sound materials, and how to organize them in time. Among the various fields of study that supported the composer's reflections were the cognitive sciences. Some composers explicitly expressed their use. What are cognitive sciences? The main goal of cognitive sciences is to explain how people arrive at different types of thinking, how they solve and learn to solve problems, and how the mind performs these operations. It is a broad interdisciplinary field that investigates the mind and its capacities, such as perception, memory, and consciousness. Precisely because it reflects on mental capacities and how humans acquire knowledge, cognitive sciences can offer a series of concepts, reflections, experiments, and insights, assisting the composer in making decisions during the composition process. Therefore, I have adopted compositional strategies inspired by concepts in this field of knowledge, particularly the theories formulated by James Tenney and Albert Bregman. In this work, I will discuss some aspects of a selection of works for guitar in which I use the concepts that Bregman formulated in his theory of auditory scene analysis, ASA. Bregman presents several useful formulations for reflection on creative and listening processes. The main concepts of his theory will be presented below. Although there are learned schemes that can be involuntarily or voluntarily triggered, Bregman proposes the existence of methods for partitioning a sound blend into separate acoustic sources that can be used before any specific knowledge about the sounds of the environment. These methods, to which he devotes most of his research, are called primitive scene analysis. According to Bregman, this primitive process of analyzing sound events uses the regularities of stimuli for perceptual organization. These regularities are described as follows. Unrelated sounds rarely start and end at exactly the same time. Gradations of change. A single sound tends to change its properties smoothly and slowly. B. A sequence of sounds from the same source tends to change its properties slowly. When a body vibrates with a repetitive period, its vibrations give rise to an acoustic pattern in which the frequency components are multiples of a common fundamental. Many changes that occur in an acoustic event will affect all components of the resulting sound in the same way and at the same time. These concepts are exemplified in a series of experiments, which also served as inspiration for me to compose several pieces, applying Bregman's concepts to composition. Consequently, I would like to share with you some technical strategies that I use and creative decisions that were based on and developed from Bregman's concepts. Let's listen to some audio examples of Professor Bregman's experiments and then I will explain how I applied them in some of my pieces. Example 1, Prelude 4, Segregation and Integration by Temporal Dilation or Contraction. This example shows the importance of speed and frequency separation of sounds in the formation of substreams. Segregation is favored both by faster sequences and by larger separations between the frequencies of high and low tones. The role of speed is seen as the sequence gradually speeds up. At slow speeds, there is no segregation, but at high speeds, there may be, depending on the frequency separation. Based on this experiment, I have used the time dilation of notes so that they do not lose the perception of belonging to the same melody, even if they are at very distant intervals. Let's see the following passage. There is an ostinato that is performed throughout the first section of the piece. At the end of this section, these notes are highlighted and are dilated temporally and intervally. Then they become the starting point for the next melody. Furthermore, as it is an ostinato, repetition generates learning that also facilitates the fusion of notes, as part of the same melody. Example 2, Elegy 2, Resulting Melody. In Elegy 2, I used several ideas inspired by Bregman's work, including the creation of a virtual melody, which only exists when the instruments play together. An experiment by Bregman that inspired me to create the central part of Elegy 2 is as follows.
Demonstration 7. Streaming in African xylophone music. First we hear one player's part, then it is joined by the second part, causing the melody and isochronous rhythm of the first part to be lost perceptually. Then the second part is played alone. Finally, when both are played together, the melody and isochronous rhythm of the second part are lost.
We will now listen to an excerpt from my Elegy 2, for guitar duo. Now, let's take a look at the score of Elegy 2. The main melody is divided between the two guitars, which when played together create a virtual melody. It does not exist when each instrumentalist plays his part alone. It is a similar effect to the hokkito. I emphasize that this melody stands out from the accompaniment due to the difference in dynamics, creating a segregation based on the difference in sound intensity of the notes played by each guitar in relation to themselves, but generating an integration between the similar dynamics between the two guitars. Thus, even being in different sound sources, the strong notes join the strong notes and the weak notes join the weak notes. Let's hear the same passage accompanying the score. Example 3, Prelude 10, latent polyphony or virtual polyphony. This idea originates from the conception of virtual polyphony or latent polyphony. Composers in the Baroque period, approximately 1600 to 1750, frequently wrote music in which individual instruments rapidly alternated between a high and a low register, giving the effect of two intertwined melodic lines, virtual polyphony or compound melodic line. While the performances were typically not fast enough to fully segregate the high and low melodic lines, it still produced a certain degree of segregation.
Demonstration 6. Segregation of high notes from low ones in a sonata by Telemann. Listen for notes or groups of notes that pop out as a separate stream.
This feature was inherited from the Baroque tradition by composers of the 20th and 21st centuries. Berio, like Baroque composers, uses the resource of the region, as well as the articulation and gradual evolution of elements, to create continuities, i.e., sound flows, individual lines. However, Berio articulates a third way of working this polyphony, no longer based on the characterization of the continuity layers of the lines, but rather through abrupt differentiation, with contrasts between modes of attack, use of extreme dynamics, extreme leaps, among others elements that can oppose. Inspired by Bregman's observations and Berio's sequences, I have used rapid dynamic contrast to create latent polyphony, as well as rapid timbre contrast through the use of extended techniques. This quick contrast allows you to unfold the instrument, creating sound flows as if they were from other instruments. Let's see how this idea was applied to the elaboration of Prelude 10. Example 4, Yuba, timbric segregation. Finally, I exemplify the use of timbre as a factor for segregating sound events.
Demonstration 9. Effects of timbre difference between the two parts in African xylophone music. The timbre difference between the two individual isochronous parts allows them to be heard individually and the emergent irregular melodies to be lost.
I used this strategy in this fragment of Yuba. Let's listen to this excerpt. As I've been looking for ways to explore the instrument's possibilities, I've been interested in the duality between sul tasto and sul ponticello techniques, as well as the sound density between the fingertip and the tip of the nail. These timbre and sound density oppositions favor the segregation of sound flows. I hope I have demonstrated how such concepts can suggest materials and guide some compositional decisions, in addition to having exemplified a little of my creative strategies. As I am a guitarist, the guitar is the first instrument on which I test ideas that I apply in larger and more complex works. Several of the strategies exemplified above are found in major and important works in my catalog, such as my operas, O Corvo and A Cardamant, my symphonies, Trini and Lubelska, Campina de Vidro, for piano and string orchestra, Aquarella Trancoso, for symphony orchestra, Meetings I, for symphony orchestra, and Marina, a string quartet, among others. I leave the discussion of the relationship between my guitar pieces and my larger pieces for another occasion. Thank you.